Hey there and welcome to another video. Today we're going to be discussing TH400 build strategies for heavy duty applications. So we have a late model TH400. It's out of a 1990 Chevy Silverado 3500 dually, and the customer is going to be using this for towing and hauling. The engine's a big block 7.4, and to my knowledge it is completely stock, unmodified. So customer uses it to tow and haul, various things, boats or small trailers and things of that nature. So we're going to beef it up appropriately, address common issues, and then kind of walk you through all the different considerations that you want to have top of mind when going back together with a TH400 intended for a heavy duty towing hauling type application. So we'll get a little bit closer to bench, walk you through everything we're going to be doing, and for my customer seeing this, he will get some insight and direct visibility, or line of sight I should say, to all the parts we're going to be installing. So let's go ahead and begin. All right, we'll start off with the basics. We have our overhaul paper and rubber kit there, along with a filter, torque converter, and all of our bolts and small parts here organized on the towel. First thing I want to touch on to any significant degree is going to be the bolt-on yoke. So when this transmission came in, the yoke was attached to it, so I had an opportunity to inspect it. And as you can see, it's got a pretty deep groove all the way around the circumference here on the journal, cut into it by the extension housing seal. When you have something like this, you want to replace this yoke. That would be my recommended course of action. There may be sleeves available that you can kind of slide over or install somehow onto the journal and basically allow you to reuse the yoke if it's not damaged in any other way, but I would just simply replace it. So this is a 1350 series U-joint style yoke. It's originally made by Spicer. This is the, I believe it's the original yoke that came with the transmission from the factory. But unfortunately, Spicer has long since put that product out of production and no longer is being made. So Powertrain Products, or Powertrain Specialties, makes replacement yokes. So it's got a full-length journal here, but otherwise is identical. It'll come with a little plug in here if it's to be used in a slip yoke type capacity, which you would just take a big drift punch and a hammer and punch it out, and that will allow you to use it as a bolt-on yoke. Alright, extension housing itself, largely unremarkable, new bushing installed, and that's basically the case of all the components inside this transmission that take bushings. We've completely replaced all of the bushings with new ones, except for the output shaft, which I'll talk about a little bit later in the video. Alright, next thing I'll touch on is going to be the valve body spacer plate. So for a heavy duty build that's otherwise going to be installed in a factory vehicle, meaning the engine power is factory, the torque converters has a factory stall in it, you don't need to be too crazy with your hole sizes in the spacer plate, and you don't need to really modify the valve body all that much. I mean, there's a lot of different things you can do with these. I'm not going to cover anywhere near to the extent that you would have a comprehensive list. It's kind of outside the scope of the video, but suffice to say, low-hanging fruit would be blocking off the 2-3 accumulator with a set screw here in this location. Right here. Alright, that'll obviously give you a much quicker 2-3 shift. And if you do that with a factory converter, you really don't need to drill the plate, to be honest. Some of these valve bodies had 2 springs in the accumulator regulator valve bore, one before it, one after it, or one inboard, one outboard. You can take the, I believe it's the outboard spring out, and that will also firm up your shifts. You could also leave check balls out of the case. This particular transmission, being a post-1988 unit, or 1988 and above, actually takes 7 check balls. The TH400s up to that point had 6. The 7th check ball was for high reverse. It was basically a flow control check ball added to aid in the timing of reverse engagement. You can leave that out if you want to, as well as the direct clutch check ball, which will also firm up your 2-3 shift. You need to have at least 2 check balls in these transmissions. You need your intermediate check ball and your low reverse check ball. If those are missing, you're going to have all kind of shifting problems with those 2 respective applied elements. Alright, for high stall applications, street strip, race, or even just passenger car that's going to see a lot more spirited driving than a heavy duty, big working truck, you'll probably want to drill your second and third feed outs a little bit more aggressively than what I show here. So for second gear, I'm thinking 85 to 93 thousandths. I haven't drilled this yet. I'm still not 100% sure what I'm going to do. Third, 100 to 110 thousandths, and you can block the accumulator off, and this should be a nice crisp shift. Crisp to firm under heavy throttle angles. All right, let's talk about this pickup tube for the filter. Now, I filmed a teardown inspection video on this transmission. It should be on the channel. If you're watching this, it would have been published about 2 weeks previously to the publication date of this video. But I noticed these two cracks here all along the case side of the pickup tube for the filter. And so if you watch that video, basically all the fibrous material was burnt to a crisp. You know, bands were shot, the clutches were all burnt. So some burglar alarms going off. This may have been a contributing factor. There were two O-rings here, as they should have been installed onto the shafter where it inserts into the case. So to what extent this impacted fluid pickup and consequently line pressure in the transmission, I couldn't tell you, but it cannot go back in like this. So I have another one on order. It should be in tomorrow. There's a few different companies that make these tubes. There's two different variants. There's a short tube and a long tube because this is a heavy duty version, you know, installed on a 1-ton pickup. It has the deep pan, so you want to make sure you install the long version, not the short version, if you're running a factory deep pan or an aftermarket deep pan, and they'll usually provide their own specific pickup tubes for you. So here's the pan. All right, new detent solenoid, new modulator. Check your modulator valve, make sure it's not all scored up, and you also want to check the modulator valve bore in the case as well. The governor is also something you want to kind of keep an eye on. The reman company that built this replaced this gear. This is a new governor gear, and it's in perfect shape. So you just want to make sure that your governor valve is moving here inside the shaft when you actuate the weights like that. And then you also want to scrutinize the cover without dropping any bolts on the floor. Okay, you want to make sure that the cover is not dented. So this cover, this little recess here is designed to allow the correct amount of longitudinal travel or play for the governor in its bore. So it's going to go in and out just a little bit. If it goes in and out too much, you're going to probably see a drop in governor pressure, and you may not have a 2-3 upshift. You know, 704s and TH350s, same deal. You know, you may not have 2-3 and 3-4 upshifts in the case of 704s. So you always want to be mindful of that. All right, as far as the speed sensor is concerned, I'm not exactly sure when they started to install fully electronic speed sensors in the TH400s. This is a 1990 model year unit, so maybe it was then, maybe it was 88. I apologize, I just simply don't know. But this one got beat up pretty bad. And it's still on the bench because unfortunately I cannot find a new or even good used replacement for it. And I'll show you a little later in the video how it got this way, or at least I'm pretty sure I know how it got this way. And you know, you'll see when I show you the output shaft that originally came out of this transmission. All right, so the only other thing I'll touch on is the accumulator piston. This one happens to be aluminum. This is the original. I have a new one here. If you have a valve body, TH400 or 350, that has a plastic piston, always replace it with an aluminum piston. Don't ever reuse the plastic one. They like to crack around the area where the little snap ring goes, and I mean, that just leads to bad things. So basically no more third gear. All right, so let's talk about the pump assembly. Much to discuss here. The valve body, the pump, the governor, and you know, separator plate and case are basically the heart of the transmission's circulatory system from a hydraulics perspective. These transmissions, or really any automatic transmission, is nothing more than a glorified hydraulic pump. And so this is the heart of the transmission. The valve body would be the brain, and then the rest of the innards and guts would be the equivalent of the skeletal system, fibrous muscle tissue, connective tissue, ligaments and joints, and the case would be the equivalent of the skin if we're trying to analogize this to that of a human being. So for your pump, most of the time when you have a high mileage TH400 come in, which is going to be most every one you see going forward, if not, at least for the last decade or so, chances are this surface here is going to be warped. And if you watch the teardown video, I showed you where we put a feeler gauge underneath a straight edge and we were able to get, I think, 2/1000ths to pass through before, we stepped up to the next size up and couldn't get it to go. So at 2/1000ths worth of undulation in the working surface there on the stator support. So had that machine flat and also installed 2 new bushings. All right, if you're fortunate enough to find the TH400 Kentmore bushing removal and reinstallation tool set, you'll have bushing drivers in there that will install every single one of these bushings to perfect depth, so that there's no guesswork involved. And that's what I use for all my TH400s. I bought it on eBay. Just keep an eye on listings there, or set up your notify me or notifications schema to get you notified anytime somebody lists that bushing driver set. I don't know what the Kentmore J number is. I'll annotate the video with it, but it makes quick work of all your bushings. Alright, for pump body, in addition to painting it, because it was kind of a nasty looking gray color, we installed a new bushing, we have a new set of pump gears, and we also have, I guess the rest of this is perfectly fine. I mean, there's no wear on the crescent, the working surface is not scored up, it's got some witness marks, but it's otherwise perfectly fine. And you can use a depth micrometer to measure your depth to confirm that along with a maybe a gauge bar if your depth micrometer doesn't have a base wide enough to span the width of the gear pocket. So new set of gears, and then for our stator sealing rings, I'm not going to install the steel rings that come in the kit, the cast steel variety. I'm going to install the Teflon sealing rings from a 480E center support onto the pump stator. I'm going to be using this tool to do it. This is a Kentmore tool, J38736-7. Get that in focus. Alright, this is for the center support. It'll size the sealing rings perfect for your stator. Alright, and then as far as your valving, so what we're going to do here is going to replace the factory boost valve and sleeve along with the factory spring with the Sonnax boost valve sleeve and spring kit. Now unfortunately I chucked the box, that's where the part number is, but I'll annotate the screen so you know what it is and what to look for. But what you're going to basically do is you're going to install the pressure regulator valve with its little horseshoe shaped spacer and the spring seat. Then you're going to replace the factory pressure regulator valve spring with the Sonnax spring. This should give you about roughly 8 to 10% in terms of linear line pressure increase or delta over what the factory spring was giving you. Okay, that's enough to kind of crisp and shifts up and shore up any other weaknesses or potential leaks in the elsewhere in the transmission that are not basically fixable. And those leaks are few and far between, but I mean, let's face it, we're dealing with something that's like 40-50 years old maybe. Cases wore out, but that's easily overcome if you shore up your hydraulics. So this will give you about 8 to 10%, and then you have a boost valve and sleeve that's brand new, and it has an O-ring set that goes on the outside of the sleeve to seal off the boost valve sleeve to inner bore perfectly. So if you were to vacuum test it, you'd have somewhere between 23 and 25 inches of vacuum. That's absolutely perfect. Alright, so that's your pump. If you install any springs that are higher pressure or designed to give you higher pressure than the Sonnax spring, and if you're racing or you have a high RPM application, you're going to want to think about restricting the converter feed orifice in the pump, and that's to prevent converter ballooning. Alright, converter ballooning is when the converter is just overcharged with pressure and basically forced violently forward against the flex plate and consequently the crankshaft that it's bolted to, which then reacts and not in a good way with the engine's thrust bearing there in the main bore. So converter ballooning can damage the engine, damage the transmission. I mean, you have a big, giant repair bill on your hands if you don't take precautions there and steps to mitigate that risk. For a heavy duty application, unless it's super, super heavy duty, it's not usually a concern. The spring, even the factory spring, if you want to add a second horseshoe shim here and run the factory spring, that'll basically give you the equivalent of what the Sonnax spring will give you. Either way, you shouldn't have any concerns when it comes to converter ballooning with that setup. Alright, so that's the pump. I have to obviously put a seal in it. Let's go ahead and move the camera down so that we can talk through the rest of the case. Okay, first thing I'll touch on is going to be our low reverse servo. So as you can see, we have a Sonnax servo pin kit here. This is part number 34912-01K. And the reason I have this is so that I can dial in my band clearance between the low reverse servo travel and the front planet and band exactly where I want it. Now, the factory has multiple different pin lengths for these servos. It's a selective part, and then they have a special tool that you can use to determine exactly which pin or version of pin you need. For most folks, they're not going to have that tool, and they're also not going to have a whole plethora of different apply pins laying around or access to them. So this basically solves that problem completely, and it also solves for a potentially worn servo pin bore. So we take a look at the instructions. You'll see that there's an O-ring here, you have an adjustment screw, and you have washers that you can use to start dialing in your overall length of travel as well as seal off a worn bore. But this is a fairly straightforward deal to work with, and basically what you want to do is adjust your screw and install whatever shims you need to, so that when you're going back with the servo, okay, before you install for the final time, and I'm just going to use a cover for reference, is what you need to do is measure your servo travel right here on the case between this bowl hole and this bowl hole location, right in the middle. And you want to see between 125 thousandths and 175 thousandths on that travel. And so you're going to install the servo just like this, as you see it here. Okay, I'm going to install this straight away and see if I have any issues, because if I don't, and this is otherwise okay, then I may not even need to use that Sonnax part. But if it's not, and most likely it's not going to be, and I'll explain why in a second, I can go ahead and then start adjusting with the adjustable pin from Sonnax. But you want to leave this seal off. Do not install your 1-2 accumulator piston or seals or anything like that. You're just going to insert it, and using all your body weight, force this thing all the way down into the bore until it stops, until it's fully applied to band, and then you're going to take your measurement. So you're going to do that with the main case fully assembled. I know Jake's has some technical articles out there, Jake's at Jake's Performance, where he shows it being done with only the gear train in, but I prefer to do it when the case is fully assembled, because that's representative of how it's going to be when it goes back on the road. Alright, so as far as clutches, steels, bands, and such, everything's high energy. So this is going to be our new coast band. And then for friction module, we're going to be using waffle style high energy Rebestis. So brand new steel module as well, also Rebestis. I like these frictions for pretty much any kind of use. I mean, factory to high performance, doesn't really matter. Borg Warner high energies are also perfectly fine. There's really not too much in the way of fussiness when it comes to TH400s and the type of frictions you need to use. If you're all out race, then maybe you want to use Rebestis Blue Plate or something else along those lines. But for this build, these type of frictions are perfectly fine. All right, for our intermediate clutch, you'll notice we have a whole smorgasbord of steel plates. I don't know, something like 8 or 9 of them there. I'm not going to obviously install all of them, but I have those. I have a 480E direct clutch, intermediate clutch spec stack up, along with several Chrysler A518 or 727 Ford clutch selective snap rings, so that I can dial in my clearance to exactly where I want it. This is the original snap ring that came with the transmission. These and 480Es use the same snap ring. I wouldn't recommend installing it. I like the heavier duty A518 snap ring instead, and that's what I believe what Transgo includes in their shift kits. You know, the next level up beyond the basic kits will have those snap rings in them. All right, for our direct clutch, we're going to run a 6 clutch, 6 steel stack up. So again, 6 frictions, 6 flat steels, and then we have a piston that we machined to accommodate that extra friction and steel. We're also going to be using a brand new 480E direct drum with the 34 element heavy duty sprag. TH400s after 1970 came with that stupid 8 element roller clutch, and you know, maybe it's 8, maybe it's 10, I'm not sure, to be honest. I don't know because I never use it in builds. I always install a 480E direct drum with a 34 element sprag, and that's just to checkmate any concerns whatsoever about that one-way clutch assembly for intermediate. There was no issues with the one that came out of this transmission, and it was working perfectly fine, but again, it is not nearly as strong as the 480E late model sprag, and that's why I like to use it. As far as your clearances, forward clutch is pretty straightforward, 10 thou per friction disc. You can run it a little tighter if you want than that. You know, if you're at 40 thousandths, that's fine. It's on all the time in any forward range position. For direct clutch, I like to see 10 thou per friction. So for this clutch pack, I'm shooting for between 60 and 70, maybe 75 thousandths tops. And then for your intermediate clutch for heavy duty builds, I like, again, somewhere between, I will say 13 to 15 thousandths of an inch per friction disc. So if you're running a 3 clutch stack, something like 40, 45-ish there to maybe 55, 60 on the high end. And then for your 4 clutch stack, maybe another 10 thou on the high end, so like 75 thousandths on the high end. The more clearance you have in this pack, the firmer it's going to shift. And that's true of all clutch packs. So you can run it a little tighter. On a low RPM application, the clutch is not going to drag, but in a high RPM application, it will in first gear, and you don't want that. So, you know, manage your clutch clearances based on application, but the guidance I just gave you should work for an overwhelming majority of TH400 builds. All right, as far as the return spring assembly, we have the heavy duty retainer here. Just the 3 springs in a low RPM application is fine. If you're high RPM, I would install all 12 of them. All right, what else did I want to chat through when it comes to clutches? Interestingly enough, if you hadn't watched the teardown video, this forward clutch piston was installed into the direct drum. Okay, this is not the original drum, obviously, but when we took it apart, we noticed the forward piston was installed in the direct clutch drum, and the direct clutch piston was installed into the forward drum. I mean, technically that's fine. I mean, they'll fit, but you don't really want to do that because this piston, if you're working with an aluminum piston, is not as robust as this piston, and this piston was designed to take shifting torque. This piston really wasn't. I mean, it could do it. And again, in a factory, you know, regular stall, regular engine, you know, no racing type situation, you could probably get away with it. Nothing is wrong with this piston, but for anything beyond that, you want to make sure you have the correct pistons in the correct drums. And so that's another thing that reman company didn't do. Technically, they did not do that correct. Let's talk about the rear gear train. So I'll move the camera down a little bit further so we can see that a little bit better. I'll show you that, output shaft, the one that originally came in with this unit, and kind of talk through what else that this reman company did that led to the damage that you saw on that speed sensor. All right, so we'll start with the front of the bench and work our way to the rear. First thing you'll notice here is a TH350 pump bearing and a whole set of shims. This is the 20 thou shim, I think, and that's typically what I'll use. Either 15 to 20 thousandths as far as the thickness of shim for most of my TH400s 480Es works when it comes to setting your rear gear train in play. So these two things are going to replace these two things. So this is going to be your 3-tab flat selective steel thrust washer for the very back of the case. It comes factory. And then this is the thrust washer that actually goes here on the rear planet. from the factory. It's a 4-tab washer for all TH400s, and then 480Es. Later model years, they went to a 2-tab washer. And so what I like to do is take the 4-tab Babbitt washer that goes on the output shaft flange and put that here instead of the plastic washer, because the plastic washer, well, it's made of plastic, it's more vulnerable. So if there's some overheating going on, you know, some intense work happening, a lot of towing or a heavy load, this is going to be a better fit for this area compared to this, and they're the exact same thickness. So I always like to put that there. All right, now here are 3 bearing assemblies, nothing remarkable about them. If they're missing needle bearings or they're burnt, obviously replace them, but otherwise they're usually fine to reuse. Now, your front planet, we have a new bushing installed, and this is why I picked up that Sonnax adjustable pin kit. That is because I had to machine, or have machined, the band surface here on the planet. When this thing came in, the band surface was heavily warped. I mean, it was ridged, it was ribbed, and it was no good. So when you machine these surfaces, you turn them down, chances are you're going to be taking about between 10 and 15 thousandths of an inch off. And that materially changes the diameter and consequently the amount of travel that this part of the band here in the middle section, the apply point, has to make to fully arrest the planet. And so that's why you want to be prepared with like an adjustable pin kit from Sonnax versus having a whole smorgasbord worth of selective factory pins, and who knows, maybe none of them work and you have to further modify. So that's a waste of time. New bushing here, as I mentioned. Let's talk about the output shaft. New bushings in a sun gear shaft. But here's the output shaft that originally came out of this transmission. So this gear is what the speedometer, or excuse me, the speed sensor reads. This is a reluctor gear. It's like a Hall effects system. This is supposed to be press fit. As you can see, it is not. And this is why it's not. Whoever worked on this thing at some point in the past absolutely butchered this poor gear. And they used a drift punch to install it onto the shaft. And they did an absolutely horrible job. I mean, you know, some gorilla went at this thing and brutalized it. So it's no longer able to fit as a press fit onto the journal there, and basically it renders that shaft worthless to be used in this transmission because it, well, uses an electronic speed sensor that needs to pick that shaft up. So with this thing moving all around on the shaft, it most certainly was coming in contact with the speed sensor and, you know, over time damaging it. So here we have a new one. Well, I should say a good used one, new to this build. Okay, and it is press fit on there, and this whole thing will pass right through the rear of the case and the bushing, so there won't be any interference. You do not need to remove that gear unless it's damaged. So I'm not sure why that gear was originally removed. Maybe it was damaged in, you know, in some other event prior to the reman company getting this cooler in, but most likely somebody removed that thinking they had to, and they realized it was, you know, they did so in error. They tried to put it back in, and they didn't have the correct installation tool, so they beat it to hell with a drift and damaged it. That's my guess. I don't know. All right. New Borg Warner low roller clutch assembly, 40971-AM or AM. All right, center support, new bushing. All right, the last thing I want to touch on when it comes to the rear gear set, and this also has to do with the direct drum, is dual feeding. Dual feeding the direct clutch. We are going to dual feed this transmission's direct clutch so that we have a much greater apply surface area and consequently a much stronger direct clutch pack than what you would get from the factory in a TH400 or 480E. So very simple. Now I'll move the camera down so you can see the direct drum again. Actually, no, it's in view. Very simple. You're going to take the center seal here. This is a new drum, so they put a seal, but we're going to take this and leave it out. Take it out, leave it out. on the center support. We're going to leave out the second from the top sealing ring. We're only going to install sealing rings here, here, and here. And if you have a lathe, you can actually just machine this entire sealing ring groove right off if you wanted to. And then we're going to install a 3/8 cup plug, 3/8 of an inch cup plug in the high reverse feed passage location in the case. That is it. That's the extent of dual feeding the direct clutch. For basically nothing other than the cost of that plug, which is like, I don't know, 50 cents maybe, you will dramatically increase the reliability and strength and torque handling capacity of your direct clutch, which in a TH400 is the most vulnerable clutch, most vulnerable applied element, all other things equal. All right, let's go over the case real quick. I'll discuss a few things, including pointing out the high reverse feed passage, so there's absolutely no mistaking as far as where that cup plug needs to go, and then we'll be done. So like I said, I want to touch on a few things as it relates to the case itself. So first and foremost, it's going to be obvious, but I'll mention it just in case. You want to check all your bores if you haven't done so already. Make sure that all of the sealing surfaces for sealing rings, lip seals, machine cut rubber seals, or whatever is nice and smooth. Okay, you don't want any scoring, any gouge marks, nothing that could cut any of those seals or O-rings or whatever. All right, next thing you want to be mindful of is potential for cross leaks here at the worm tracks. TH400s, 350, 700 R4s are what we call a closed case design. Okay, that's my term. You're probably not going to hear it or see it in technical manuals, but my definition of a closed case design is one where the all of the hydraulic circuitry on the case is covering either the entirety of the belly of the case or a preponderance of it. In other words, you can't reach through this area to get into the barrel of the case like you can if you were working on a C6, C4, 727. Those are open case designs. Okay, all of the hydraulic circuitry is just on either one side or the other, and the rest of this area is just wide open, and you can see the drums and planets and whatnot. Tendency for high spots will occur on some of the crests or the tops of each of these partitions, so you want to take a 400 grit piece of sandpaper, a sheet of it, 8 by 11 or whatever, as well as a Durablock, a perfectly flat piece of finished wood, say like something roughly the dimensions of a 2x4, or a piece of machine bar stock, steel or aluminum, and just go over the worm tracks multiple times until you knock down all your high spots. And ideally you want to do this right after you disassemble the transmission. Okay, before you put this thing through the cleaning cycle so that you can get rid of all the, shavings and aluminum dust and whatever. All right, third thing is going to be the rear case bushing. So you want to make sure you install your rear case bushing, whether you're using a TH400 bushing or a no-walk bushing or whatever. You want to make sure that a little bit of the bushing protrudes into the case so that you can give the bearing that's going to go back there, that TH350 pump bearing, you need to give it something to locate on. So I'll show you what I mean. Turn the case so that you can see directly into it. Now a little bit more. That should be good. All right, so you notice there's a lip. So let me go ahead and zoom in a little bit so you can see it a bit better. All right, so you'll notice that a little bit of that bushing is protruding into the case. Now I'm going to grab my bearing and my 20 thou shim. Typically, I will use either a 15 or a 20 thou shim to set up my rear gear train end play. That usually works most of the time. And so you want to have it locate. Now, because this is angled, it's not going to just rest there, but that's how it should be. And if you need to knock the bushing in a little bit further, just, because there's not enough to install both the bushing and the shim, then just go ahead and knock it in further. You want to do that, obviously, before you do anything else. This really should be among the first things you do when it comes to case preparation. All right, let me get the case back vertical, and then I'll point out
the high reverse feed passage where you need to install your 3/8 of an inch cup plug. Okay, it's going to be right here on the right side of the center support feed bolt hole location. Now, if you want to use a set screw in there, you can do that too. I mean, it doesn't really matter as long as it's plugged. I believe the Transgo 1 and 2 kit has a spacer plate that dual feeds a direct clutch via the plate. You can also, pin shut or weld shut the feed location for high reverse in the spacer plate as well. I've found that not to be necessary. You want to install this cup plug after the case is fully assembled. Put a little bit of Loctite or RTV, just a very thin coat on the outside of the plug, and then use a drift to seat it and just install it until it comes to a full stop on the center support. And you'll still be able to remove the center support if you need to for whatever reason. You have to go back inside the case without taking the plug out. It's not going to interfere with the center support's travel. All right, I think that about does it as far as everything I wanted to cover on the TH400 and build considerations for heavy-duty type applications. I mean, there's certainly other things you can do. You want to install a billet roll-rise for a clutch hub, you can. It's usually not necessary. I mean, those things aren't really needed until your RPMs, climb honestly above 5,000 on a regular basis. The factory piece is perfectly fine at stock power levels with low RPM type usage patterns. So it's up to you if you want to install. It's really not necessary, but shoring up your hydraulics, getting your clearances in your clutch packs and your low reverse band servo correct to where they need to be, making sure that your pump's in good order, and making sure that all parts are serviceable is going to go a long way into ensuring that your rebuild is successful for whatever application that you have it intended for. So in case of heavy duty, what I showed you is going to be sufficient for a stock to mildly modified engine in a heavy-duty truck or SUV. All right, guys, thanks so much for watching. Greatly appreciate it. If you have any questions or comments, go ahead and leave them below. If there's anything else you want me to cover with respect to TH400s, go ahead and leave it in the comments. I'll prioritize the video as soon as I can. Until then, enjoy the rest of your day or evening. Look forward to seeing you again on the next video. And once again, I thank you so much for spending your valuable time on my channel.